Hello, everyone, and welcome to today's session, Adopting DevOps with Amazon's Web Services. My name is Archana Krishna, and I'm a Senior Business Intelligence and Analytics Consultant at Thorogood. I'm joining you today from our offices in Philadelphia. Feel free to also get in touch with me directly via the contact details on the screen, and I'll bring this up at the end of the session as well. Here's the agenda for today's session. I'll kick off with a brief introduction to Thorogood. I'll then talk a bit about DevOps, what it is and why it's so frequently spoken about these days, and more importantly, how it fits into the world of BI and analytics. I'll then move on to looking at the different processes and techniques of DevOps with an AWS lens on it, and we'll dive deeper into some of these concepts with the help of a demonstration as well. So a quick introduction for those of you who don't know Thorogood. We are an independent professional services consulting firm specializing in business intelligence and analytics solutions. We operate as a single organization serving our customers globally with our consultants in our offices in New York, Philadelphia, and Sao Paulo in the Americas region, and London, Bangalore, and Singapore. All of our consultants are recruited and trained in the same way to develop a unique mix of skills blending business understanding, technical aptitude, and a deep understanding of analytical tools and techniques. We offer a full range of services right from BI strategy and roadmaps, architectural recommendations and design, solution design, end-to-end implementation, and data services and support for production applications. We also support our customers in user training and empowerment programs, which we're seeing a whole lot of these days, particularly with organizations looking to adopt the self-service culture. In terms of the technologies we work with, we are an independent consulting firm, meaning we don't align with one specific technology. We work and partner with most of the major players in the BI and analytics market across back-end, front-end, and analytics-driven technologies. We've been working with several customers in implementing their DevOps frameworks using tools both natively available on some of the major cloud platforms and also other independent or third-party tools. Our independence means we are able to develop well-rounded expertise that allows us to help our customers integrate across these technologies successfully. So today's topic, what is DevOps? There is no one standard definition to DevOps, but a useful way to look at it is DevOps is a collection of philosophies, tools, and culture that enables streamlining the software delivery lifecycle. We live in a very competitive and fast-paced world, and there's a strong demand for everything to be done quicker, not just in the IT world, but in every walk of life. DevOps has taken on increased significance these days as it looks to address the constant need for responsiveness and enables teams and processes to be more efficient and reliable. All of this leading to a rapid pace of innovation and growth. This obviously helps organizations to be more competitive in the market and achieve what's critical at the end of the day, satisfied customers. So let's look at DevOps from three different angles, starting with people. DevOps is a combination of two words, developers and operations. These two groups of people, those who develop or create code, and those who support, maintain, and deploy code, have always been two distinct groups that work in silos. One of the key principles of DevOps is changing that culture and removing the barrier. The objective is really to drive increased collaboration between these user groups using tools and techniques that result in higher quality and more efficient outputs. DevOps first originated in the late 2000s, first in the manufacturing process, but it's also very closely related to the growth and popularity of the Agile methodology. Agile methodologies were being adopted to develop software and solutions more efficiently and in tune with customer demands. DevOps practices is an extension to this as it endeavors to increase productivity in the end-to-end cycle of delivering solutions and not just the development phase. We'll talk about what these processes look like in a little bit more detail. And finally, in order to successfully implement new processes and these new ways of working, we will need a set of tools to build this framework and put all the theory into action. Today's session is really going to focus on the process and tools sections. But let's take one step back. To keep up with all of the changing dynamics of today's market and the increasing competition, we are seeing companies create new business processes or rethink existing ones using digital technologies. This is what's known as digital transformation. Everyone's on this journey, albeit at different stages. Two key enablers of these digitally driven changes are the cloud and DevOps. It is interesting how cloud and DevOps complement each other, and the way we approach each of these domains are hugely influenced and driven by the other. Let's start with looking at some of the key benefits of adopting the cloud. It enables us to be agile in experimenting with new initiatives and responding quickly to changing business demands. It is quicker to realize value via the cloud platform. With a reduced wait time to create infrastructure resources, it's possible to deliver outputs faster. It also offers a highly scalable environment that can be easily managed in response to your IT and business needs, and also reduces the dependency on your organization's IT and existing internal infrastructure. And very similarly, DevOps drives agility in the process of building, testing, and releasing solutions. Automating these processes reduces dependency on manual effort and leads to an increase in productivity and quicker results. Cloud computing really has been critical to driving digital transformation, but it is by combining that with the advanced tools and processes enabled via DevOps that we're able to tap into a lot of the potential that's available to drive digital transformation at a much larger scale. For example, we're able to quickly spin up a development environment on a cloud platform, but supplementing that with the automated processes for delivery and testing provides end-to-end benefits and really completes that full circle. Let's now look at some of the key DevOps processes and their relevance to BI and analytics. How DevOps is designed and applied to BI and analytics is entirely different to software development, and I'll call out some of the key considerations and differentiating factors at each stage. Continuous integration and continuous delivery, also known as CI/CD. These processes and principles enable teams to deliver code more frequently and reliably. With the need for fast-paced development, it's equally, if not more important, that our processes and solutions work consistently and adhere to defined quality standards. We've spoken a bit about being able to spin up resources quickly on a cloud platform. A related benefit of working on the cloud is that these resources can also be managed via code, and DevOps allows for managing the provisioning of these code-based infrastructure resources and the automation of all of these workflows. You're probably familiar with version control. It is about versioning your code, having a central code repository for databases, testing scripts, ETL processes, and more. The objective is to have a single version of truth, and whilst we've probably implemented version control in some form or the other, we will look at some of the tools available and how they integrate with the other DevOps practices. The ability to track all of the activities on a platform is key to understanding what's going on, what's working well, and what may need addressing. Monitoring processes allows you to be responsive and adapt to various situations, be it user or environment-driven. And the last one on today's list is microservices. Now, this refers to an architectural pattern of designing a solution using small independent components that can function on its own, but can also be combined to form a much larger system. Typically in BI applications, we see a lot of interdependence between the different layers, so it's not quite as straightforward to completely split things up into smaller independent building blocks, and therefore not all of the microservices features may be relevant for BI development. Having said that, there are some offerings within this space which could be quite interesting, and we'll have a look at that shortly. For all of these processes to be successfully put into practice, there is a critical component of planning and management required. For example, the ability to link a particular change request or incident with the associated code in the repository and the related release process. That provides complete visibility to all of the activities being carried out. There are several tools available for this very purpose. Something that we've used quite extensively is Jira. Amazon Web Services is the largest player amongst the cloud platforms and most certainly a leader in this space. We'll look at how AWS enables us to implement each of these DevOps techniques, but a word of caution before we go there. Anyone familiar with the AWS offerings will be aware that there's an incredibly large number of tools and services available. And whilst we're only going to be looking at the DevOps-specific tools today, there may still be a lot of names flying around. But it is worth recognizing that whilst there are plenty of options available, you don't have to use all of them. The approach would really be to pick and choose what is relevant to your organization in terms of culture and technology landscape. So let's start looking into each of these processes. We'll start with CI/CD, which is definitely one of the most critical components of the DevOps framework. It lays the foundation for a streamlined process by which you develop code, test your changes, and finally release it, starting with the development environment and then higher environments like UAT and production, for example. Yes, a BI application may not evolve or need to evolve as quickly as a software product. Our applications are immensely complex though, and typically with each change, there's a considerable amount of testing involved. We also tend to bundle up plenty of changes together to make the testing and deployment process more efficient. So this is exactly where the CI/CD processes are beneficial. By setting up processes to continuously merge new changes with the master version, we can better modularize changes. The automated testing component is really valuable because we can now build in scenarios for unit testing, end-to-end system testing, and regression testing. Obviously, not all of the testing can be automated, but a lot of the standard data quality and integrity checks can be built into our workflows, which could see a whole lot of time savings. And finally, with continuous delivery tools, we can build one-click deployment processes and not have to really document detailed release steps for someone else to manually run. AWS offers a set of tools to implement these CI/CD processes. Code Pipeline is an orchestration tool used to build pipelines, and a pipeline may invoke other tools to deploy or build code. So that's code deploy or code build. AWS also integrates well with other third-party tools, and some of which are depicted here. We're currently working with a global organization here in the US where we're using Bamboo as the primary pipeline tool to build and test solutions on the AWS platform. Some of the considerations that go into deciding which tool to use are, do you already have investments in a certain tool or platform that you can just reuse? You may want the pipeline to integrate with other source systems or repositories, and in that case, connectivity could be a key criteria. Amazon was the first cloud vendor to offer capabilities related to managing infrastructure as a code, and it did this via CloudFormation. What this means is that you're writing down all of the details related to a server or a database and reusing that piece of code to create a new resource. This again is pretty applicable for BI, as typical solution architectures will invariably have several components like databases, ETL tools, modeling, and reporting instances. By managing a database instance using code, we have complete visibility and transparency to how it was configured. It's also easily repeatable for different environments. And more interestingly, it's a powerful tool when you're evaluating the cost versus performance trade-off, as you can now switch off your resources when they're not being used, or maybe dial up the power of your servers during a peak reporting period. Version control management systems have been around for a long time, and I'm sure anyone who's been associated with development teams at any point would have been through a situation where code has been lost or changes have been made on the wrong source code, for example. So the need for a version control tool cannot be underestimated. AWS's offering in this space is called Code Commit, which is essentially privately hosted GitHub repositories, and GitHub is really one of the most extensively used version control tools out there. Based on the CI/CD pipeline tool that you use and the integration that offers, you can use any compatible version control software, and I've called out some of the options over here. Again, your choice of tools would be influenced by any existing investment that you already have, and if not, Code Commit offers a very compelling option when working on the AWS platform. We've discussed how DevOps focuses on fostering a culture where you're able to effectively respond to changing needs and situations, and the monitoring and logging tools allow you to do exactly that. There's a vast amount of data that's collected and made available, like memory utilization, performance metrics, what services are being accessed, what is active, inactive, and a lot more. Two of the tools that allow you to manage and govern the AWS platform are CloudWatch and CloudTrail. We just spoke about using infrastructure as code to power up and down resources. This can be based on certain events or triggers that are captured via these monitoring tools. For example, if the memory utilization of a server exceeds a certain threshold, you may want to consider turning up the power for a specific duration of time. Or you could just simply have it notify the administrator so they're alerted of a potential situation and can take appropriate actions. I alluded earlier to how it can be argued how relevant microservices is to BI and analytics. But one of the tools that AWS offers in this space is called AWS Lambda. What AWS Lambda offers is the ability to run code without having to take care of the server, the compute, or the storage resources. All of that is fully managed by Lambda. It supports a list of languages, and all that you need to do is upload code in one of those languages, and it can be executed on demand. A great place to leverage this would be in automated testing scenarios, and we'll look at one such example shortly. So that was an overview of some of the AWS tools that can be used to put all of these DevOps techniques to practice. Let's use an example to look at how some of these tools work with each other. The scenario we have here is of a typical solution architecture that has been developed on the AWS platform. Data is moving through different layers from a raw format to an output format, with processing steps in between each of the S3 buckets, which are just logical folder groupings. This is then loaded into a relational database service, which is the source for your reporting needs. As you can see, there are several components, and each of them may be carefully configured with lots of different properties and security rules applied, similar to what you'd see with most enterprise-scale solutions. Thinking of a situation where we need to spin up a UAT in production environment, there'd be a lot of manual work involved to create each of these services one by one. Of course, one of the benefits of a cloud platform is that creating resources is fairly easy and straightforward. But with large solutions like this, there's still a lot of effort required to create the service once and maybe multiple times and get it right always. So let's look at how we can use some of these tools that we've been talking about in managing this infrastructure as a code and how that helps in achieving a level of automation and efficiency. I'm now logged into the AWS console, and I'm within the code pipeline window, which you may remember as the orchestration tool. Opening up this particular pipeline over here. So opening up this pipeline over here, what we're seeing is really a group of tasks grouped into different containers. So we've got some source bucket over here and a deploy section over here. So what it's doing is it's got your infrastructure as code, these templated files which have all of the properties configured. That's in place in an Amazon S3 bucket. And we're going to pull up the files from there and use that to spin up these resources. That's the general workflow of this pipeline, but we'll go into a little bit more detail to see how that's actually configured. So if I step into this source bucket, I've got this referring to my Amazon S3 bucket. I've specified the bucket name and that particular zip file which has all of the different templates hosted in it. I've used S3 in this instance, but you can also see that the source can pull from other GitHub repositories as well. So now that we've defined the source, we go into the deploy stage. I've included a step for manual approval just as an interception point, so there is some level of oversight and confirmation that this deployment is ready to go ahead. And once that approval has come through, the pipeline workflow jumps into the deploy stage. And in this case, it's calling up AWS CloudFormation. CloudFormation, you may remember, is the tool that's used to create these new resources. So it has its own UI. If you upload these template files, it'll create resources over there as well. But that would be a manual process. By invoking CloudFormation within this code pipeline workflow, you're automating that entire process. There are a number of other options available, and you may recognize some of these names from our conversation earlier. So you've got a combination of both native AWS tools, but also other third-party tools. Now, this workflow gets triggered every time there is a change in your source file. Or you can also set it to trigger when there is a particular manual input that you have customized. So taking a step back, this is the process that you would follow if you're trying to spin up new resources. In this case, I've just got an EC2 instance and an RDS instance, which is a database. But there could be many more steps based on the complexity of your architecture. Whilst this is doing the deployment, I'd like to take it a step further by adding some testing activities. So what I want to do is I've spun up a database. I want to test that the connections work. I can create tables, and that all of the security rules I've applied actually work as expected. So in this case, I'm going to switch to AWS Lambda. So Lambda is the ability to run code without having provisioned any server. So what I've got over here is a very small snippet of a Python code, which, if you can see, is connecting to an RDS database over there and just executing some basic operations to validate that I can connect to the database and I'm getting the outputs as needed. This is typically known as a smoke test. Now, what I'd like to do is include this particular Lambda function within my code pipeline, and that's just another additional task to add to that pipeline. By doing that, what you're really doing is combining the automated testing activity into that continuous delivery pipeline, so basically that end-to-end deployment. And a lot of the manual process that you typically have to do when you're deploying these new services or your post-deployment checks get automated and saves you that trouble of going in and performing an additional step. So hopefully that gives you a flavor for how some of these different DevOps processes come together and how the DevOps tools can be used to implement such a scenario. So let's just quickly look at that from a diagrammatic point of view. We're using code pipeline as the main orchestration tool. The source code or templates are pulled from a repository, an S3 bucket in this case. Subject to approval, code pipeline calls AWS CloudFormation to create these new services, and further testing can also be set up using these Lambda functions. Now, setting up this automated deployment process or managing infrastructure as code not only eliminates that manual dependency, but it also sets up a process that is robust, resilient, and more scalable. We've used an example of one solution over here, but really the value of processes like this is that it can be easily scaled to an enterprise scale and to realize huge benefits. Setting up infrastructure as code frameworks such as this for all of the resources deployed in your organization helps achieve consistencies and a uniform standard of development. And in a very similar fashion, you can define processes for automated release management, development, and testing as well. With that, we come to the end of today's session. I hope you found this useful. If you have any questions or are interested to learn more, please don't hesitate to reach out. Once again, thank you very much for joining me today and have a good rest of your day.